So we'll record this one. Those of you who are watching this at home, I'm going to be standing up a fair bit, walking away from the microphone, but I'll yell, turn it up at home, and you'll hear it, I hope, because I have lots of cool demos to do here. Newton's third law. Newton's third law, Mr. Goulet is very fond of quoting, as a matter of fact, and it's usually phrased something like this: for every action there is an equal and opposite reaction, which to me is about as confusing as you could possibly. I mean, it's kind of poetic, it's got kind of a rhyming rhythm to it, I'll grant you that. But when I first saw that, my first reaction was, huh? So here's Mr. Dueck's version. Forces come in pairs. Forces come in pairs. Forces come in pairs. You cannot have a single force by itself. Forces always come in pairs. Or if I want to say it mathematically, if I apply a force F, if object A applies a force F on object B, then object B applies a force F on object A, except in the opposite direction, so we'll call it negative. Call it negative. Let me give you a few examples here. Newton's third law: for every action, there is an equal and opposite reaction. What he means is for every force, there's an equal and opposite force in the opposite direction. You know what? Forces come in pairs. If A applies a force on B, B applies a force back on A, same magnitude, opposite direction. How does Newton's third law help explain why it's difficult to walk or drive on ice? Okay. So we would say this: the force that causes cars to turn, or causes us to turn when we're walking or starting or stopping, is friction. Not our feet, not the tires. Friction. So, ice has little friction. Doesn't quite have no friction, so you can get a very, very small amount of traction. You can, if you're careful, exert small amounts of force. Even, you may have noticed, actually, as a matter of fact, on good tread, like when you're on a field or something like that, if you're playing sports and you really try and accelerate hard, your foot slips because you pushed backwards harder than, just like when Dom pushed against the scale. You pushed backwards harder than friction could handle, so I'm sorry, then you have an unbalanced force, your foot's going to slip backwards, you're going to lose your grip. Okay? How does Newton's third law help explain why professional boxers need to wear gloves? How about we'll write it as an equation? F of hand on face equals F of what? Face on hand. You know what? Let's make them vectors, in which case I would call one of them negative, because it's the opposite direction. Okay. It's one of the ways that you know all those movie fights are fake, because in a movie fight, they'll punch at each other for 60 seconds or 2 minutes or 3 minutes, and then afterwards, you'll see the hero holding a cup of coffee in his hand. No problem. He'd break most of the bones in his hand, always. Oh, so I guess part of the moral of the story is, and I guess I'm speaking mostly to guys, but somewhat to girls, hey, don't fight. It's stupid. You're only going to hurt yourself, and there's the physics behind it. I've got a couple of cool videos to show you. Put your pencils down. So we have Newton's first, the law of inertia. Objects want to keep going in a straight line at a steady speed. Or if they're not going in a straight line at a steady speed, then there must be an unbalanced force. Newton's second, F equals ma, which we're going to look at in all sorts of different variations. Oh, Newton's third, forces come in pairs. For every action, there is an equal and opposite reaction. Next page. I want to talk about mass and weight. Mass is measured in kilograms. Weight is measured in newtons. Weight is a force. Mass is a scalar. It's kilograms. So read along with me. It says this: comparing the concepts of mass and weight, one is basic, fundamental. Oh, you know what? I think we're actually into the homework, Mr. Dueck. I think we're actually done the lesson. Good gosh, here. So I think this actually, I forgot to write at the very top here, homework for lesson 1. There we go. So what did we say? Weight is mg. It's mass times gravity. It's the force of gravity. Mass is mass. So your homework, we'll go over these next class, is to work on this. Then classify each of the following events as examples of Newton's first law or Newton's third law and defend your answer. And Newton's third law then asks, what's the reaction force to the action force? What's the pair to each of the following situations? See if you can figure out some of this stuff here. All right? I'm going to press pause on the lesson.